Hello and welcome to another video of Cornerstones of Math. In this video, we will be dealing with vectors. That already sounds really exciting, so let us dive right into the problem here. Consider a tetrahedron ABCD. Let vector AB as vector A, vector BC as vector B, and vector CD as vector C. Let P be the point on the edge AD that satisfies the ratio AP to PD equals 1 to 2, and let Q be on the point on the edge BC that satisfies the ratio BQ to QC equals 1 to 3. Express vector PQ in terms of vectors A, B, and C. Alright, before we handle this specific problem, let us remind some of the most basic properties on vector operations, such as how do we add the vectors? For example, for these two given vectors A and B, what is the vector A plus B? Well, the first thing you have to do is to translate the vector B so that the tail of vector B coincides with the head of vector A, in this example, at this point B. Next, you draw an arrow from the tail of vector A to the head of vector B, then you obtain a vector A plus B. We can also write this as, for vector AB plus vector BC, we can delete this middle point B, which is the head of the first vector and the tail of the second vector, and simply write vector AC. And we can utilize the reverse process of this to sort of split the given vector. For example, for this vector AB, we can take arbitrary points P and Q and split this vector AB into vectors AP plus PQ plus QB. Alright, so now let us apply this to our main problem here. Note that vector PQ can be expressed as, if we take this alternate path from P to Q, we can say vector PQ equals vector PA plus vector AB plus vector BQ. And since this vector AB is simply vector A, we can write vector PA plus vector A plus vector BQ. So we have to find these two vectors PA and BQ. And let us actually start with vector BQ first, because you can easily notice that this vector BQ is parallel to this vector B. This means that vector BQ can be expressed as a scalar multiple of vector B, that is, vector BQ equals t times vector B for some real number t. So what is the value of this t? Well, since the ratio BQ to QC is 1 to 3, this vector BQ equals 1/4 of vector B. Next, this vector PA. This vector is parallel to vector dA, and from this ratio of 1 to 2, we can say that PA equals 1/3 of vector dA. Here, this vector dA is simply minus vector AD, and this vector AD can be expressed as the sum AB plus BC plus CD. So we have vector PA equals minus 1/3 vector A plus vector B plus vector C. So we have found everything we need. So finally, using these, we can find the vector PQ in terms of vectors A, B, and C, which is first vector PA, so minus 1/3 vectors A plus B plus C, then vector A plus vector BQ, so 1/4 vector B, so minus 1/3 A minus 1/3 B minus 1/3 C plus A plus 1/4 B. So we have vector A here and here, which gives 2/3 vector A, and we have vector B here and vector B here, which gives minus 1/12 vector B, then minus 1/3 vector C. And this is the answer. Thank you all for watching, and I will see you in another video.